Hello, everyone. I would like to introduce Inspire East African Network. I am Sylvia Muyingo from the African Population and Health Research Center. And in this presentation, I would like to talk about building a fair, sustainable, harmonized COVID-19 data platform to inform policymakers and researchers in Kenya and Malawi. I'm presenting for panel session 36. Abstract 20. So the Inspire East African Network is a network that was set up in 2019 for data producers and longitudinal population-based studies that includes health demographic surveillance systems. And this builds on previous investments by in-depth and alpha networks that were collecting data on HIV. So the HDSS brings in data from several research institutions, several research institutions, and other data providers all bringing data into the Inspire East African Data Hub. We also have Alpha, which is looking at HIV, ANDLA for non-communicable diseases and other users who provide data to the hub. And overseeing the hub is a governance and management structure. And within that, there's the running the OMOP common data model on a cloud server that is producing harmonized fair data and using the demographic and population disease data with standard vocabularies for cohort search. The Inspire Pitch platform, which is what I'm talking about today, is a platform for evaluation and analysis of COVID-19 harmonized data. So under this common data model, we're building a platform as a service for COVID-19 data to develop the key elements of a coordinated Pan-African COVID-19 data ecosystem with oversight through a trusted, equitable governance and policy environment, and utilizing this data standards and technologies and data integration methods that are looking at bringing together multiple sources of data. This requires new ontologies and vocabularies, particularly in low middle income countries, and developing new analyses using the power of artificial intelligence and data science. So data from two countries, Kenya and Malawi, is used here. The two countries adopted different strategies in combating the pandemic, and we are looking at integrating aggregate data and environmental data with individual and longitudinal population surveillance data. Thank you. Over to Jim on how to set up a common data model using OMOP for COVID-19. Thank you.
Thank you very much, Sylvia. I'm going to be talking about the middle part of the Inspire network, which is about the setting up of the common data model using the Observational Medical Outcomes Partnership database for COVID-19 data and the applications that we've used for that. The Inspire Common Data Model, as we've said, is based upon the OMOP Common Data Model, which we've run on the Microsoft Azure cloud service. This allows data to be entered into the database directly, or it allows federated workflow where the data remain on the data producer's computers, but is only used for the applications that are needed. In all cases, the data ownership will remain with the producers of the data. The database itself needs to have data coming into the model, which we call the on-ramps, and it needs to have ways of getting data out of the model in order to be able to analyze it. For the on-ramps, we identify the data with the common data, data producers, and then we've developed extraction, transformation, and loading programs in order to be able to take the data in the formats produced by the data producers and put that into the OMOP common data model. These data can be from population data, and they can be from clinical records. The big strength of the OMOP data model is that it has the potential for many different diseases, each of which can be stored within the common data model. And we've used this for HIV as well as for COVID-19. We can also extend this to look at other types of data, not just clinical records and population health data, but also about relationships within the community, about environmental data, and socioeconomic data to get wealth scores for households within our communities. For the off-ramps, we can develop work streams so that we can actually get the data for either HIV or COVID-19 and use that for the analysis of our data. One of these ways is to use a dashboard, which will use the OMOP Atlas program in order to be able to analyze the data for sentinel surveillance and universal health coverage. We can develop bespoke data analysis programs in order to get the data for advanced analyses, including things like causal loop diagrams. And we can develop online databases, flat files, in order for traditional analysis of the data as well. The big thing about the OMOP data is that it needs to have standardized vocabularies. It needs to have a very good metadata developed in order to be able to understand what the data are from many different sources. And because OMOP has been developed mostly for clinical data, then Inspire has constructed some new vocabularies for COVID data. These are based upon not just the WHO case record forms, but also upon questionnaires which are delivered to individuals within the community, such as the Wellcome Trust questionnaire for low and middle income countries. These new vocabularies will supplement the standardized vocabularies which are available in OMOP. These vocabularies from SNOMED and from LOINC. And surveys often organize their data in a different way from OMOP. They organize it hierarchically with panels, with a question and an answer pairs which are introduced. And so the vocabularies will need to be adjusted to show how these concepts can be included inside an Inspire folk summary where they develop the OMOP vocabulary that is needed for the data. Within our Inspire network, we've realized there are some data challenges and we've developed some potential solutions to this. One of the biggest challenges was that OMOP data has not been used in Africa very much and is not used for population and public health applications. It's mostly used for clinical data and for case records within a hospital setting. And so we've needed to train data professionals in the new data techniques which are available for Inspire. And we have developed some training modules for Inspire personnel, which we hope can then be used for other personnel outside of Inspire once we've got them established. We've also set up an African chapter of ODESI. ODESI is the oversight organization for the OMOP databases, and we would like to use that in order to get some help to make OMOP more applicable for population and public health data, because those are areas which it hasn't been used for up until now. In the future, we hope to integrate OMOP with national routine data. This will include things like the district health information systems and also the HIV service data, such as the CTC dataset in Tanzania. This will help us to bring in stakeholders, the ministries, and the data producers in a more equitable way so that they can all share the data and use it for influencing policy in many countries. That's all I'm going to say now. I'm going to hand back to Sylvia to talk about how we can build the advisory group for stakeholders in the OMOP, with the OMOP database. Sylvia, over to you.
Thanks, Jim. In the second part of this presentation, I'll talk about building an advisory group for stakeholders that includes policymakers and Ministry of Health planners, with the aim of setting up training sessions to show how the data are created and utilized. Our communication goal is that we need a trusted and responsible governance AI data ecosystem to improve the COVID-19 pandemic health response by the end of 2022. The key messages we are bringing on are the engagement with different stakeholders in Kenya and Malawi to obtain the anonymized data and build capacity for access and utility of the data, and to create awareness among communities and potential beneficiaries of the research, and to engage potential research collaborators who are our boundary partners, at the same time advocating for policy change or influence by continuously engaging key decision makers and continuously communicating and branding our products via social media and websites. Our key stakeholders and audiences, based on our outcomes for the communication. So our outcomes are looking at improving knowledge and capacity of the actors and improving communication and simulating dialogue among policy and decision makers. So we are looking at positive forces for driving this change, being civil society and advocacy organizations. We're also looking at funding. So we need to prioritize this. And then there's public demand for the initiatives we are taking on. The negative forces, we look at time. We are time bound by the project timelines, and being aware of that is necessary to get this moving. So we are also looking at private companies that are doing sort of similar work, but we might have added value in other things that we are taking on, and would like to build the synergy around those, engaging with those private sector or private companies. We also know that we are aware that the governments have priority interests that may be different from what we are doing, but we would like to co-create the activities within this work with the governments. In terms of progress, we're looking at the actors that are the advocacy groups, and we have shared interests with them in terms of influencing policies and looking at targeted policies that ensure equity. What we expect to see is that they participate in impact group thematic meetings that are driving our outcomes. They read our briefs, and we would like to see that the team advance our cause in advocating for use of AI and data science in this pandemic response, in engaging with the Ministry of Health and other actors. And what we would love to see is that they put pressure on governments to influence issues on policy. They also act to improve citizen voice and looking at accountability mechanisms for better engagement with the public. We also have other state actors, the state actors that we hope or expect they'll participate in discussions of the new concepts around AI and also reading our briefs. And we would like to see governments at the forefront of championing the use of AI, introduce new concepts and that frame debates, ongoing debates in the longer term, and also improve the knowledge and capacity for actors through this, the products that we share. So other non-state actors, we're hoping to build and we are building the relationship with the Ministry of Health and engaging other non-government bodies to see the involvement with Ministry of Health, with other players in the field, raising awareness on the use of these tools and issues in pandemic response, while providing governance and a financing framework for the work around AI and data science to influence policy. In developing our communication strategy, we're looking at the key drivers or positive drivers as being the advocacy groups, the public demand, whereby we describe that we'll raise awareness through media and through other engagements with those advocacy groups. We will share best practices and simulate policy dialogues, working with the private sector and civil society organizations, with the aim of changing or gaining active support from advocacy groups in simulating policy dialogues for the use of artificial intelligence and data science, looking at transparency and equitable response to the pandemic. While the advocacy groups are very key, they are not the final authority on matters of policy. So that is seen as a negative driver. So there's also the resistance from governments to make their data open access, or fear around that. And that is seen with many countries, not just Kenya and Malawi. And the focus on AI as a policy for just COVID-19 may not be in the key interest of governments. So they might like to see a broader policy, not just around COVID-19. So in terms of identifying our resources and capacity to implement activities, some of the highlights are on the looking at provision of a review of methods and looking at the data and fair and equitable research opportunities, lessons from other pandemics, and how to develop accessible, transparent, and responsible AI, linking data from multiple sources. So we need to synthesize the knowledge through an expert leading this process. We also hope to generate evidence on the situation of AI in communities, generate this evidence with working with other advocacy groups. And for that, we need to package our evidence for public health use with the support of the advocacy groups that are working with the communities at grassroots. We're also working with communities in seeing how and developing series of dialogues and live discussions on programs around AI issues with coalition groups and advocacy groups. And we see that here the capacity needed is to package the translation of science jargon into local simple language. And that also goes to the shared products and a need for policy and use of those products. So the training platform that we are developing, which is a virtual platform, aims to enhance capacity of individuals and in building their skills and competencies about the use of AI in public health, and also developing an understanding of AI-related issues, but also looking at enhancing communications programs, looking at AI at institutional level and some systematic level. The governance and sustainability oversees the infrastructure, the technical infrastructure, and also the other components of this work. So here we're looking at setting up an advisory group to oversee the data generation cycle beyond COVID-19. So governance is based on the experience we've gained from the working with in-depth and alpha networks, and we are currently working on the Supreme network. This reflects also that the advisory group will reflect the diversity in knowledge and skills, even the professional, scientific, geography, civil society, data advocates, community, and perhaps funders. We will develop a strategic framework with this advisory group, and they will advise on administrative and organizational matters relating to the project. They'll also support background research and pitching material, developing pitching material for outreach and engagement with stakeholders, and ensure that the activities and products support the use of evidence and transparency in decision making. Thank you. I'll hand over to my colleague Amelia to take you through the analysis part. Thank you.
The analysis of harmonized data, including the creation of dashboards for the prevalence and incidence of COVID-19, it's an important part of this project. We are developing advanced analysis using artificial intelligence and machine learning to bring together aggregate data together with the individual data. Agencies such as the Ministry of Health lack end-to-end visibility and understanding of their data. Health data may reside in many different systems that are containing structured or unstructured data. For example, in Malawi, there are over 100 different health information systems that have been developed and are in use, either in government hospitals, private clinics, or NGO-run projects. There are also challenges to do with data accessibility, integrity, and quality. Therefore, our approach includes initially engaging in what we call a data archaeology process. This covers the discovery and the cataloging of valuable health data. In this respect, AI-powered tools for tagging, clustering, and identifying similarities and patterns in the data will prove very useful. There is also scope to use AI techniques to automate the metadata definition and production, and to augment sets of documents with additional metadata to enable information access and compliance. A second problem that we are tackling is the limitation that the current data visualization tools have. Data visualization is limited to a reporting function. This is usually done by means of static dashboards and pivot tables. However, this suffers from a lack of structure for facilitating data mining methods. Our approach is to engage in the creation of a semantic representation of the clinical data and observational data to benefit cross-domain AI analytics and data explanation activities. To this extent, the use of the OMOP model will be crucial. We will look into the customization and extension of data models, vocabularies, concepts, and the development of semantic model. This, we hope, will facilitate the intelligent query and visualization of the data. The third aspect of our research is to explore the use of artificial intelligence for epidemiological risk modeling and biomedical informatics. These are growing areas of interest. Epidemiological risk models require the assembly, modeling, and risk mapping of large-scale representative community studies and other granular data that can take into account the many dimensions of the health environment, multiple infections, and multiple interventions. Here we feel that our approach in engaging the OMOP model, in engaging into an AI-enabled cataloging and building of semantic models of the data, will serve as building blocks for building epidemiological models. At the same time, we hope to develop data sets that can be used for biomedical informatics research. Particularly, we will develop tools for detecting and quantifying any biases in the data and algorithms to ensure an African perspective to the AI development. Thank you. Over to you, Sylvia.
So thanks, Amelia. bringing all of this together, we see that the OMOP common data model is feasible and useful, and the training of data professionals is needed, is a much needed initiative, and has been highlighted by many of the stakeholders. And the governance is needed to ensure the equity of the data and its use. So new methods for data analysis provide insights into the pandemic response, and dashboards provide real-time results and are useful in providing decision makers a tool that can be used to influence policy or influence policy actions. Thank you.